Good afternoon, everybody. Welcome on in. Hope everyone is doing well. Hope you're all healthy, happy, and all those things. I hope you're all got a good start to your weekend. And I know it's an interesting one here because we're getting it's quite the quite the temperature change today. We're to about up in the high 80s here today, just randomly out of the blue. But it's funny too because I was like, I would really like to open the windows to, air out the house a little bit. But I know if I do that, the ambient temperature inside the house is just going to go up. And lo and behold, it has. Because it was at a good 69 before I opened the windows, and now it's up around 73 or so. So, but get some fresh air out of it. So I mean that's always a good thing anyway. And I'm not going to turn on the air conditioner yet. I refuse. I refuse. It's too early. But yeah, it's definitely not. It's definitely rather warm coming through here. So I got to figure out where we left off with. I left all these tabs open. So it looks like we're in chapter 6, and it looks like we were starting the vertex buffer structure thing here. I just need to see where that is at. Fucking buffer. Because I think we've gone through this stuff. Vertex description. So I think we're at the vertex description part here, I guess, is probably where I was. I imagine. So we'll have to kind of pick up from there. Hey! Hey, D-Wave, welcome on in. How are you doing? How's it going? How are you feeling? How are you doing? Let's see. So I think this is where we left off, but let me just see here. So vertex buffer structure. This is the problem with like not working on it for a couple weeks, is that I'm now like, where the hell did I leave off? What was I doing? Where am I? And who am I? Let's see. Vertex buffer structure. So I have that. What was I looking at here? Oh, I see. Okay, so I had just finished the vertex buffer structure. And I guess I was going to the vertex input state info, I guess. Vertex buffer structure, input state info. Vulkan buffer. Doing a triangle. Did I do the Vulkan buffer? Oh, I have the vertex input state info. Oh, and I did do the Vulkan buffer. Vertex buffer structure. Okay. So then there's a base vertex input state info. Right. All right, because this is an abstract class. Got it. That's why I did that. Okay. All right, so then where does that put me in here? Vulkan buffer, tills, vertex description, vertex buffer structure. Input state info. So did I make the correct changes here? I guess the question. So we have text buffer structure, bindings. So I guess I was looking at what they had changed here. Oh, this is a new class. Vertex buffer structure. So this whole thing's brand new. So then, whoops, what am I looking for? Over here. So I have that whole thing done. I think probably I stopped after finishing this. Yeah, okay. All right, I think I'm getting back on track here. So then come down to loading the data. All right. Data for our models and their formats. Vulkan model, which will hold the information for 3D models. Okay. All right, so then look at that. Create index buffers, create vertex buffers. Transfer command, transform models. Okay. So a lot of this looks like the methods that were in the OpenGL stuff too, but it's definitely got Vulkan things in it. So I'm going to make this up just as it is, because I think I'm going to start getting really confused if I deviate too much, even though I don't really care to generate just a triangle. But let's see where we can go with this. So we need a model ID and the list Vulkan mesh. Vulkan mesh list. Where is that? Is that just a... I guess that's not a class that they do. That's a actual name of a class they pull in here. Okay. Alright, so let's get this going. So we have an asset thing there. So I'm going to do that here as well. Call it assets. And do new class. I'll call it model. Okay, so model ID and the mesh lists. It's really a ID. And let's see where we get this from. I'm guessing this will be coming from VK11 or okay, it doesn't come from there. Let's play. Where the frick does this come from? Hmm. From there. There's gotta be a... thing here that I've missed? Collection of meshes. Oh, it's a record inside here, Vulcan mesh. I got it. Okay. It's right there in front of me. Okay. So public record Vulcan mesh. Text buffer, index buffer. Index buffer. Index buffer, and then number of indices. I had this turned off here. Where's the settings? Key map, Copilot. I do have that set up. All right. Let's turn that off so it stops bugging me. Next buffer, number of indices. Oh, I turned this off. Screw you, I turned these off. So, what do we have here? Void cleanup. Damn you! How many times do I have to say turn off? Jesus Christ! I hate fucking IntelliJ. I absolutely hate it with every fiber of my being. Like, it is the worst IDE ever fucking devised here. Copilot disable completions. Inherited from Copilot enable completions was that one, disabled. Just click on that and just... Jeez, oh, he's still doing it, you son of a bitch. Stop it. swear to God, I want to find the person at JetBrains that is responsible for this IDE, and I want to strangle them. I really do. I don't know what is actually triggering it. Inlay hints. What is this? That's not it. What's doing that? I don't know what's doing it, but it's driving me absolutely up a wall. Full line completion. Can I do that? Hey, that's better. That thing pop up in your face just drives me nuts. There we go. We have that defined now. So I can go just getters for both of these. Okay. So have transfer buffers, private record transfer buffers, source buffer, destination buffer. Okay. Alright, public Vulkan model string ID. Right, is that what this takes? Yep. Go. Got that. And Okay. And let's see. Create index buffers. Model data, mesh data. We don't have model data yet, do we? Okay, let's put that under scene. Let's do model data and scene here first, because I have a feeling those are going to be important. We'll come back to this. All right, we've got model data and then scene. Let's do new. Mesh data lists, and then model ID. Okay, so ID and a mesh data lists. Oh, that's literally all it is? Okay. Well, we'll do auto-generate a constructor. And then we'll auto-generate the getters here. Okay, and then there's a scene here. Public scene just has... It's just a placeholder right now. Okay. Takes a window. Right. Okay. So we have that. I'm presuming that we're going to save the window here. So we're going to do private. Let's do that much anyway. All right, so then back to model here. And we're doing mesh data. Okay, so we got the create index buffers, create vertex buffers. All right, so transfer buffers. Why is that? Why does that return a transfer buffers? Source and destination. I guess that'll become clear a little bit later. Oh, these are also static. I don't know, something, it's fine, I guess. I hate how they've structured this. I really do. Like, they rely so heavily on these, and these are private static methods. Like, what is the... I'm struggling with the point of making those static. So there's a public static transform models. Does that... So that's why they made it static, because they made this transform model static. Command pool Q. This model data, this model data, I don't like what they're doing there. I guess I'll do it though. I think this is this has got like code smells all over it. You know what I mean? This is like, this looks like something that was copy pasted from C, potentially, and not redone to make sense in an object-oriented language. Because it feels completely out of place. Like it's bringing back a list of Vulkan model. It's inside the Vulkan model class. What is it doing? It's creating a new array list. Command buffer. It's going over the model data list. It's going over the model data list to record the commands. How is it? Model data list is passed in. And it's returning I hate this. I really do. Like this is this kind of sticks out like a sore thumb, along with the great buffers things. Like they're like mixing two things here. Like this is holding information, but it's also acting as a utility, and it's just it doesn't make any sense. Like I would expect this to be a Hey Igor, welcome on in. How are you doing? This I don't like this at all. I really don't. I'm trying to think in my mind how to unravel this nonsense into something that makes more sense to me. That's going to make sense to me later on. Like when I have to go find it again. Staging buffer list. Huh. Ooh, no idea. Because there was a Linux again. Yeah, this is on Linux. Yeah. Because how did I do? See, the model over here made sense. It was just a holder for stuff. And the loader just processes stuff. But then, was it mesh? Did I put everything together? Yeah, so mesh. has all the vertices and indices and texture coordinates and all that stuff. And then there's entity that does the actual translation and rotation. And I feel like this is the same thing, it's just they've called it something different. Mesh list. Do we add to the mesh list here? Who adds to this? You do. The transform models does. And what is... so Vulkan Mesh is just the vertex buffer, index buffer, and a number of indices. And a cleanup method. Yeah, so model is... Let me think. Oh, let me think. If... buffer... Transfer buffers. So what is in destination buffer? Vertex buffer bit. To see. Okay. 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 So I hate this because it means that I'm gonna have to, like, if I change this, I'm gonna bet the next chapter are gonna mess around with this method and add more stuff to it that will become incompatible with how I move things around. What I'm more curious about is Vulkan Mesh. Transform meshes loading their data into GPU buffers. Mesh data. The mesh data is just positions and indices. So that's what I'm confused about, because that's the positions and indices of the entire object mesh. So why is it putting it into a list at all? Like that's what doesn't make sense to me. Is like, you have a model, it has a mesh. Like why is there a list of them here? I mean, my guess is they're going to do something with scenes later that involves some nonsense with this stuff, but like, I mean, I guess a model could have multiple meshes, but I feel like that would be a different model. Number of positions length. Yeah, you know what? Screw this. I'm going to do it the way that I think it ought to be done. And then we'll see if I have to completely redo it when the next chapter rolls around. Because this doesn't make a lick of sense to me. What they're calling, like they're calling apples oranges and oranges bananas. It's throwing me off here. Because to me, the model should look a lot like this, where you've got, you know, a list of materials, you've got a pointer to the entities themselves, right? And then when we go to entity, that's got all of the model matrix stuff, the position, the rotation, and then the mesh has all the vertices and the texture coordinates and all of that stuff. Right. And then the entity has a model ID and where's the material there? So the model has a material list and it has the entities that are modeled after that model. We got the textures themselves, which are fine. Yeah, I'm going to make it look more like that and see what happens. I know they're different beasts and all, but this is... this is kind of craziness here. So this is not Vulkan model. This is Vulkan mesh. Right, and then actually, we have a Vulkan mesh, right? Oh, well, that's the record here. It's fine. So, vertex buffer, index buffer. Let's do this. Let's go. Private Vulkan buffer, vertex buffer. Buffer. Right, and then we'll get rid of this. And we'll put this clean up out here. I can leave the transfer buffers there for now. Okay. See if I can bring some sanity to this. Bring some kind of... It's not even that I'm bringing sanity to it. It's more like I'm trying to do it in a way that I will know what the F I did. Theoretically. You know, put like things together, not dissimilar things together. All right, so now we have that. Transform models. So we call create index buffers. This will be public then now. And because I'm doing that, I don't need to return anything. I can just say void create index buffer. Right. Device is, what did I call that? Physical device. Okay. And then that has mesh data, which is Positions and indices. Okay. And that should just be a regular class, I feel like. Yeah, but let's do this. Java class, finish data. And it's float. Positions and indices. Okay, and then get rid of it from here. That. And when I come back up here, all right, so those will already be loaded up. So then we'll just say, so create index dot has to take that in. What are we doing here with this now? Indices. Number of indices. Put indices. Okay, so we just need, so we need the number of indices. Which is, where's that used? It's used to get the buffer size. Okay. So really we just need the buffer size. Length. Times graph constants int length. And how's graph constants? Is that system? VK 14 dot. Oh, let's play find damn imports. Graph constants. Graph constants. probably, no, that's... Oh, it is here. So graph constants, do I guess I don't have that. It's a better name than that, but let's do, what is in here? Let's call it what it is. Size constants. Matrix 4x4 size. Public static file. It's float length. Go. And then here is in length. Okay. And then we create the source and destination buffers. Okay. Device, buffer size. And VK 14 VK buffer usage transfer source bits. And then memory property host visible bits. Host visible bit board with host coherent bits. Property host. These coherent bits. So this doesn't take physical device. What does this take? Logical device. Okay. So I did have the wrong one there. problem. Change that. A little bit easier here and do destination buffer, so device buffer size, destination bits, and then buffer usage index buffer bits. Buffer usage, okay. Wait a second. Oh, destination and destination ORed with buffer usage index buffer bit. Okay. I was like, there's not enough parameters here. What is it called? Buffer usage index buffer bit. Index buffer bit. Okay. And then the mask is memory property device local bits. Okay. That's a ton of stuff right there for that. Map to memory, source buffer map, int buffer, map to memory, source buffer get requested size, source buffer unmap, and then turn new transfer buffers, source and destination buffer. Source buffer unmap. When you call, I mean, we have an unmap method there, right? So yeah, it sets it to null. So it's no longer valid. So what is the point of keeping that around if it's no longer valid? Because we're keeping it alive with the transfer buffers here. And I don't know why that's... Oh, down here it's doing source buffer? This, but they've been unmapped, so they're not valid? Or are they still valid? Yeah, we call VK unmapped memory. And then set the memory handle to null. So if you're adding those invalid buffers to the staging buffer list, I don't don't understand that. There's an order of operations here that I'm missing. Index vertices. Transfer, and then we're calling record transfer command and we're actually using that buffer. Something's not adding up here. That doesn't make any sense. Why you would map it to memory. Data, but and then the destination buffer is not getting anything in it. Data put positions is going into a float buffer. What? That doesn't make any sense. What is the point of this? Like they're allocating a float buffer that is the size of the source buffer, which they have mapped into memory. Or they've gotten a location of that mapped memory, and then they're using that to create a buffer of that size. Then they're putting all the positions up here into that buffer, and then immediately unmapping it. Like, that doesn't make any sense. She just went through all that trouble to put that stuff into memory, and then you unmap. Well, you didn't clear it, so unmapping doesn't clear it out of memory, right? It's just unmapping it from God knows what. Unmapped a previously mapped memory object. Okay, so that's still out there in memory. It's just now floating around in an unmapped memory location. Okay. So then when you create they're doing the same thing for the index buffers. Okay. And once you've created those, adding a source buffer. To the list, recording a transfer command. Which is command copy buffer, so it's copying the source buffer to the destination buffer. Okay. What a back-asswards way of doing things. Like, seriously. Like, I don't... And this is not a criticism of this code. This is a criticism of the Vulkan library. Like, what a weird, stupid way of doing things. Like, it's just like, yeah, let's build up a buffer just to copy it to another buffer. It's like, okay. Yet somehow this is faster. I don't know. It's very silly. It feels like. It feels like the kind of thing you would get from something that was developed by committee instead of developed by somebody that actually gave a damn. Oh, hey, Ram, welcome on in. I don't have any specific game in mind. I'm more learning how engines work. So it's most likely going to be a space game of some kind. But right now I'm in like the very, very early stages of just trying to learn how to do things, how to write an engine. And I've got like the OpenGL stuff, loading up a model and I can spin it with the keyboard. And now I'm trying to do the same thing with Vulkan. And really my goal at the end of all this is just to learn how to do it. Whether or not any actual game comes out the other end is a bonus. Really at this point. No. And honestly, it's a challenge because most of this stuff is written in C and C++, and there's not very good information, learning materials out there for how to do it in Java, even though we have these excellent libraries like LWJGL. There's no real like I'm looking at a book now online on how to do things, but really a lot of the stuff looks like it was just copy pasted from how to do it in C. And so I'm also doing it for the challenge of it. Since I'm most familiar with Java, I feel like it'd be good if I could figure something out here. Figure out how this goes together. So how's the progress so far? It's steady, but it's slow. Like I'm still in the very, 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 very early stages of all this. Like I said, I've got like OpenGL loading. I can load up a model and I can spin it, and listen to keyboard commands and stuff like that. But that's all I can do. I can't and I can't resize the window yet and all that stuff. I have to do all that still. And I can't load more than one model and all that stuff. With the Vulkan thing, I'm trying to get the Vulkan side of things up to the same level where I can load up a model and spin it and all that stuff. It's just that Vulkan it's just taking so much more time because it's there's a lot of groundwork you have to put in place. That there's a lot of boilerplate and stuff that probably shouldn't even be necessary, but it is because of how they've designed Vulkan. So, and I use the word design lovingly. Has the same Vulkan concepts under hood, and it just exposes C++ wrappers and Java and let you work it out. Exactly. I mean, that's what's basically happening, is that all this stuff is being LWJGL is just providing a wrapper to take the C libraries and use them in Java directly. And it's a nice wrapper. I mean, it does, it exposes the things it needs to, but it also it also doesn't go much further than that, it looks like. Like there's areas where it could do a lot more. It could, make the memory mapping and all that stuff not be so stringent and whatnot. And they've done a few things. They have utilities and stuff, but at the end of the day, you still need to kind of you do things you don't normally have to do in Java. Like you have to manage, you have to do a lot of memory management. So you have to create the memory, you have to destroy the memory, when you're done with it and all that stuff because of the underlying library that you're using. And they do help a little bit with it, but it really should be more turnkey than it really is right now, I feel like. But what's more weird about it is that they don't really, you have this library that's been put together that's fairly robust. It's actually very robust. This whole wrapper and everything, and it's been used successfully by games in the past, and yet their training materials on it, their documentation on it is just really poor. It's not like I can just open up a manual and look at stuff or get grab a book and learn how to do stuff. Like, yes, there's some resources on there. I'm using one now, but they are very suspect because they cover the basics, but they don't really cover the basics. Like they just kind of, it looks like the code is out of date in many cases, and a lot of it looks like it's just been copy pasted from other sources and just changed to be Java in the very littlest amount of change. So we don't really have a good, what I would say, reliable training source for how to use this, in Java, and it's just kind of, it's weird. I mean, I get it. On the one hand, there's not too many people doing it, but on the other hand, the quality of what I'm seeing out there is very is much less quality than I would expect. Like if I was looking at Python or something, doing game development in there, suddenly you get a wealth of good resources to look at. And then as soon as you switch to Java, it's like you got someone that slaps something together in 20 minutes, you know, and it doesn't really explain anything. If I tried following the C, C++ examples and porting it myself to Java, sure, and I could do some of that. The problem again is trying to figure out what the lightweight Java game programming library offers, right? Because yes, I can go directly and do stuff, but there's convenience methods that have been put together in LWJGL to help with certain tasks like memory initializations and mallocs and all that stuff. And so it's not so much a matter of doing a one-to-one mapping as it is you can certainly do that, but it's also I'd like to know what the library offers for me to make things easier and more consistent and all that stuff. And that's kind of the part that's why I'm looking at specific things here, because I'm trying to see what that library brings to the table. Because otherwise there'd be no point in using it. I would just pull in, you know, Joggle and Joel and whatever the wrapper is called around Vulkan, you know, and then use them directly instead of going through this larger framework kind of thing. So that's my problem right now is that I want to use this larger framework because I'm assuming it's got some convenience methods in there, and it looks like it does. But it's also, it doesn't do a very good job of explaining itself, you know? Also, on top of that, it's been 20 years since I've done anything in C and C++. So, bit rusty in that regard as well. I think most of the stuff is in C, so it's probably not that bad. But yeah, it's been a while, and I was like, yeah, let me just see what someone else has done first, and I can kind of take it from there, you know? More of a documentation issue. Yeah, it is. It really is, because they don't really for everything that they do, for everything that they bring to the table and all the good stuff that they're doing, they haven't really spent any time trying to show people how to use their library. You know, you know, they're not alone in that. There's a lot of libraries that are like that it's just nobody wants to write documentation, and I get it. You know, as a developer myself, I don't like writing documentation either. But like, if you want people to adopt your library and all the hard work you've done, you got to put some time in and show them how it works, show them why it's better than just doing it themselves, you know? Why, you know, what advantages this bring more than just a high level bullet point, you know, like go in and show like what this should look like. And what bothers me even more about it is that the examples that they do have on their website, if I compare the example that they have on their website to an example of how to use, say, OpenGL in the C library, it looks like they just went through and copied them and then just made them, you know, made the few changes they needed to make to have it work in Java. And it's like, that's not how someone who understands Java is going to approach this, right? Like it's not going to be a one-to-one copy. I want to, you know, because the C side is functional and the Java side is object-oriented, right? So right away, I'm going to want to model things differently. And I'm going to want to use stuff that the JVM gives me. And, you know, convenience is there, and it just seems like they slap this thing together and then just say, whatever, you'll figure it out. You know, it's like it seems like the audience that they were going for was people who write in C, and I can almost guarantee somebody who writes in C is not going to suddenly switch over to Java to do game development. They're going to stick with they're going to stick with C because everything, they have more resources at their disposal. You know what I mean? So as far as I can tell, they only provide direct Vulkan bindings, which may be why I get that impression. Sure, yeah, they haven't really... It does seem like they haven't put any extra stuff into there, whereas with the OpenGL stuff, it seems like there's been extra attention paid to it, which some of that could also be because of the relative newness of Vulkan as well, so I can kind of get that. Maybe that's their goal, lightweight suggests? Sure, but that's a cop-out, right? That's like... I could call anything lightweight and say, oh, well, I don't need to provide you with any decent documentation because it's lightweight. It's like, well, that's not how that works. Right, you know what I mean? I know a few people who would jump through these kinds of hoops then to switch languages. Yeah, I mean, but I mean that's my thing, right? Like, you would think. I mean, that's the other part of this that intrigues me, is that the lack of this kind of beginner documentation when it comes to, like, someone who is not a beginner to Java, but rather a beginner to game dev, but knows Java well, makes me wonder why you've got so many people, so many of these, you know, influencers and whatnot, who love challenges, and yet no one has taken up the challenge of, like, making some good learning tools on someone who's trying to do this, right? For Java, at least. Because you would think, I mean, I know a lot of people who would jump on the opportunity to, like, oh, this is a challenge, I gotta figure this thing out. Let's figure out the best way to do this. Let's make this happen. And I'm surprised at just how lacking it is right now, with that. You know, like, everyone's content to make yet another how to do it in C for beginners thing than how to do it in Java for beginners or for advanced Java developers, you know, which is just kind of weird. It's just kind of weird, because even as I go through this book here, it just sort of, it's, I mean, it's good to be able to see somebody's code that works. I mean, that's 80% of the 80% of the formula, but at the same time, like, it's not, I don't know. It's weird. I don't, yeah. Like, it would have been nicer to have, like, a step-by-step thing. Like, here's your first bit of doing this, and here's why you do this, and all that stuff. And they do explain a little bit of the whys here. But it's, I mean, the other part of it too is they're dealing with something that under the covers is not the greatest either. I mean, so, like, when it comes to OpenGL, it was a breeze. Like, within, like, 3 chapters of the book, you're already making models and all that stuff, right? Because it was designed with that in mind. It was designed with, you know, getting you the tools you need to get things done. And with Vulkan, it's like they kind of tried to be everything to everyone. So they're trying to, you know, games can use it, but also, you know, other applications can use it and all this stuff. And so they made it so generic to cover all those bases that you're then stuck doing all of this tons and tons of boilerplate code, which most of which for a game is not even really necessary, right? Like setting up the buffers for a game, like having to check if your device has graphics capabilities and all this stuff, like that could have easily been abstracted away into a portion of the Vulkan library that is for game development. Like they could have had a Vulkan for game developers library that had, or at least some methods in there, some convenience methods in there, where you're just like, hey, I'm writing a game, and it just sets all the correct stuff for you, right? And then you can just go in and tweak things as you need to tweak them. The fact that you have to basically copy paste large swaths of of stuff from one project to another is just kind of silly. But that just comes down to, you know, that's what happens when you design something to try to be everything to everyone instead of like spending some time and figuring out what your primary uses are going to be for it, you know? At least this code seems readable. I've seen worse. Yeah, no, it's definitely readable. There's some, as I'm struggling with here, there's some questionable verbiage, calling model, what you're calling a model versus what you're calling a mesh versus all this other stuff. So I've been kind of struggling to put things where I can remember where they're at. But yeah, it's so SDL, Raylib, do for, yeah, exactly. And I have a book that I was looking at on one of the libraries, one of the other popular libraries that's out there. That's, I think, a mostly 2D library, and that looked interesting too. I forget, was it SDL? It might have been SDL. I don't remember. But it has like Java bindings and stuff too. Yeah, it was interesting stuff, and I'd like to look at that at some point too, because my goal is to just learn. But yeah, and then there's also like, I could have looked at JMonkey engine, which is more of an engine, like it's already kind of put together. So you're not necessarily, it's already got all the stuff it needs to do for OpenGL and all that stuff, and it handles all that for you. And I had thought about doing like learning JMonkey engine, and I realized like, well, it's good, but you're really using that if you want to get something done, which is a weird thing to say, but like you're using that if you already have a goal in mind for like the game you're playing, and you already know what you're doing to an extent. You just want it to be done and working, and that's fine. But for me, for learning, I'd like to try and get a little bit deeper down and see if I can figure things out, like compiling shaders and all that stuff, like having a shader compiler. Like I was working on that a little bit and things like that. Like I kind of want to, I'm one of those people that learns by doing. So for me, doing it the hard way once is good, because then I can come back around and do it the easy way. And then I know a little bit more. I understand a little bit better what's going on under the covers, you know? Which is why when people ask what game am I making, I'm just like, it'll be something. I'm not too concerned about it, right? Like, I just want to have an engine. I just want to know how an engine works. I want to see all these. I want to understand some things, maybe, possibly. And then at the end of all this, maybe I'll just, go learn JMonkey Engine or something and make an actual game out of that. What is... Huh. What is going on here? Am I still live? Yeah, it looks like it. Well, that was weird. Screen went blank for a second. Okay. I think we're okay. That was weird. My screen went blank for a second, and then I got the like USB disconnect and reconnect sound, which is weird. Anyway, Vulkan exposed all the details the GPU driver usually handles for you in exchange for more control and performance. So there's a steeper learning curve. Yeah, I'm seeing that. I'm seeing that going on. And again, I understand what their initial goal was. Their goal was to just allow you full control because they don't want to dictate what you can or can't do. So if you're just using the GPU to do, calculations, or using it for scientific work or something that's non-graphical, you can still use Vulkan for that and do all that stuff. Whereas OpenGL, you can, but you have to use the different OpenGL flavors. Which honestly, I kind of wish Vulkan would have done the same thing, which is just have the different flavors like OpenGL does, so that if you just want to use the GPU as a powerful CPU, then you can. But if you're trying to do something like gaming or stuff, like have another fork of it for the gaming things. But I can also see it from the developer's perspective, where they're like, well, we don't want to deal with multiple forks of our product, essentially forks of our product, and we don't, we just want to have one unified thing, and that's fine. But it also means that they've, like, as much as I rely on hash maps to carry data around, man, they're relying so much on structures. It's like, oh, you want to do that thing? Populate 5 of these structures, and then call these 3 methods over here. It's like structure all over the place. Like, I can't imagine how many typedef structs they have in their C library. It's got to be at least 100, if not more, for every conceivable thing. So it's just, and so you end up in this pattern where it's just like you're just filling in the blanks. There's no rhyme or reason to why you have to create these 25 structures. You're just doing it because it's required to do so, right? Even though those structures will never change and never be different for anything you're trying to do, you still have to make them, and that's where the kind of the wasteful part comes in, right? Because there's a way you can do that and still give people power over changing those to whatever they need or tweaking them however they need. So, but it is what it is. It is what it is. So I gotta, these index buffers. It annoys me that it just annoys me to no end that we're creating this source buffer, populating it, then unmapping it, eventually transferring it over to destination buffer, and then presumably at some point we're mapping the destination buffer. It feels like such a freaking waste. It just feels like a waste to me, right? It's like, and it's also, it also doesn't, it reads weirdly as well. Because when I saw this and I saw this, I was like, oh, wait, we went and put all this stuff into this data structure and then we removed it, but we're not actually removing it from memory. We're just unmapping that segment of memory, which is just, we're going through all the problems of making two buffers, populating one of those buffers, only to then immediately have that transferred over to the other buffer. It's just like, and I get that there's some mechanism going on under the covers where it's trying to, you know, it's basically doing a swapping a memory pointer around, but like, it just makes for code that is more head scratching than it feels like it ought to be. Hardware wise, there isn't a way around it, I think. Well, I guess. I mean, yeah. Yeah. It's, I don't know. I don't know. In my mind, there's an extra operation in there, which is the actual moving of the pointer around. Which, granted, it's not as expensive as as copying all the memory over. So it's just mapping it from one to the next, but this is just one of those things I have to get used to, I guess, with the Vulkan stuff, is that it really doesn't do anything for you at all. Like, you're basically having to set these things up that really it ought to handle on its own. You want to use trying to put the data on the GPU's on-chip RAM, which isn't accessible directly through the CPU. You have to fill the CPU RAM and tell the GPU to copy the bytes to the PCIe bus. You want to use GPU's RAM is because it's faster access for rendering operations. Sure, okay, I get that. I get that part of it. And I'm not disagreeing that it doesn't have to happen, because yes, you can't directly access that. You have to have it mapped via the drivers and stuff. It just annoys me that it's a necessary operation that should be automatically taken care of. Like, to me, forcing the developer to do this insists that that you don't have to do it, even though you do. So if it has to happen that way, then why doesn't it just do it? You know what I mean? Like, it's that's the part that's throwing me off. It's like, if there's no other way to do it, then why are you forcing this code to be written in the first place? Technically, you don't have to. Yeah, I suppose. I mean, I guess you could do the slower operation of trying to read from main memory, I guess. But I don't know. I don't know. It's just, it bothers me a little bit when I see this stuff. Because I think about, like, if I were writing a library that I wanted people to use, what would I do? And I definitely wouldn't do this. I would definitely provide some kind of convenience method for that. Um, and it also worries me that when I'm looking at stuff like this, that there isn't a convenience method that exists already, and I just have no idea what it would be called to do it for you. You know what I mean? Like, because I see this and I go, oh, well, that, looks like it was copy pasted from somewhere else. Is there not something already available that just takes care of that for you? But I don't know. I'm nothing if not bitchy about things that can't be helped for whatever reason. Their goal was to just provide direct wrappers and not any abstractions. Yeah. And again, I think that's a cop-out. I mean, but that's neither here nor there. I can't do anything about that. That was what they decided to do. It is what it is. I don't necessarily buy that there's a performance hit by having abstractions, because if you do it right, there'll be a little bit of a performance hit, but it would be not noticeable probably if you do it right. Simply just throwing it out there and hoping for the best is, I don't know. It's annoying. I'm just surprised that, like, I mean, I get it. It's, you do this once and then you never do it again, but doing it the first time really sucks. It really sucks doing it for the first time. I mean, after this, it's probably nothing, right? Like, I'd never have to touch it again, probably, but it's still. They either don't want to deal with creating abstractions or didn't know how to create a good one. Yeah. I mean, it's true. Either one of those could be true. And again, I'm not saying that what they did is necessarily bad. I'm saying that I wouldn't have done it that way. Given the option, I wouldn't have done it that way. I would have done it probably closer to what OpenGL does, honestly. Because at the end of the day, you want people to be able to, well, you want people to be successful using your library. And the more roadblocks you put into place to that success, the worse you're perceived, either rightly or wrongly. Buffer. what is this? Just the data. And source buffer, get requested size. Why would... Is there not one of these that takes a long... Oh. No, there's not. It would have told me here. Oh, whatever. Okay. Put indices and unmap. Mesh data, indices, and then what else they do? Unmap. And then return this. You could create your own. Maybe people start using yours. Yeah. If only I was good at hardware. I'm not. I've never been good at hardware stuff. I'm constantly amazed at people who can reverse engineer and all that stuff, hardware things. Like it just never clicked in my brain how to do it. I wish I could figure it out, but just never did. And I like emulation and stuff too. And I've in the past dabbled in trying to make emulators and things, but I've always run into the same problem, which is understanding hardware things. Like I understand assembly language, I understand machine language, and I can understand registers and all that stuff, but trying to understand like the picture processing unit and the audio chips and all that stuff, and the different, like for the NES, the different memory mappers they had and stuff like that. That stuff really cooked my brain at points. I mean, there's a lot better information now than there was when I was looking at it, but it still always has. I've always found it difficult to like model hardware in the software, and how that works. Although I've had a crazy idea of like doing an emulator that's just it's not even really an emulator, it's more of a cross compiler, and just like grabbing the console games and the binary code from them and just cross compiling it to something that would run on a modern PC. And I'm sure, I think there were people that have done something similar, particularly for like PlayStation stuff, I think. But it's not really a true emulator because you're not emulating the hardware at the time. You're just emulating the calls and the callbacks and the interrupts and all that stuff. And so consequently you're likely running at a different speed than the game would have been running at on legitimate hardware, and that throws all kinds of things off. Do I need hardware knowledge to write my own LWJGL? LWJGL? Probably not, no. No, I thought you were talking about writing my own Vulkan-like libraries. For that, I would need to know hardware stuff. But like, an LWJGL kind of thing? No, you probably wouldn't. You would just need to know how to... You just need to know how the underlying libraries work. And also, the hardest, I think really the hardest part of that is the JNI, the Java JNI stuff, the native interface, because there is a lot of optimizations that don't make a whole lot of sense, but if you understand how the Java JNI stuff works, it makes more sense. In other words, like there's certain ways to do things that makes the JVM perform better when it's doing native calls than you would think if you were writing just a regular Java program without the use of native calls. And then also like the JVM, they've been updating it a lot over the years of particularly around like the performance around the native interface and all that stuff. So there's a lot of new things that you would never touch in any other context that you just kind of have to look at and see, oh, okay, this is how this works or how that works. And those kinds of things are like good luck finding examples on using those things, because so few people use them on a day-to-day basis that would be another one of those, like, you know, archaeological expeditions to try to figure out, you know, how certain things work there. So from that perspective, like, I think what the LWJGL guys have done is phenomenal, right? Like which is why it bugs me that they don't have very good training resources, right? Because I think they've put a lot of effort in here, and it's a lot of good effort. It's just they haven't they haven't highlighted any of that effort. You know? You can build on top of it and expose more idiomatic abstractions for Java for others to use. Yeah, that had occurred to me too. Like, I was thinking to myself as I'm going through this, I was thinking to myself, you know, I could take a whole bunch of this boilerplate code that exists here, and I could throw it in a jar file and say, here is, you know, here's Vulkan for J, right? And just like, if you want to use the Vulkan abstractions in conjunction with LWJGL, just bringing this jar file in. It's got a whole bunch of utility methods. It's got a whole bunch of things that you can just call to get started rapidly and easily. So I have thought about that, yeah. And I would like to go down that path just even for myself, just so that, like, because I have a feeling this won't be the first engine that I try to write, or at least the first game on an engine that I try to write. So it would be nice if I could make something that was a little bit easier to grok along the way. But, you know, we'll see. I have to actually understand what I'm doing to be able to do that. And I'm only partially understanding what I'm doing at the moment. At the best, I'm partially understanding what I'm doing. I would need more. I would need to actually write a proper game that actually works and functions the way I want it to before I'd feel comfortable enough even doing something like that. You know. And right now I just want to get past the, well, I could show a blank screen stage. Right? No hello triangle. Well, at the end of this chapter, you're supposed to be able to show a triangle. So we're almost there. We're almost to the triangle stage. But as you can see, I'm only part of the way through this chapter. And I'm all... part of the problem is I'm looking at the stuff and I'm going, I don't like this. I want to change this. And so I'm changing stuff as I go to something that I feel like I will understand better later on. Or something that more resembles what I did for OpenGL. Because I would like to, like, some of this, like the model loading and stuff like that, like some of that, like the model loader, like I feel like a lot of this I could use outside of both OpenGL and Vulkan, right? Like I feel like this, I could maybe just use this as is, and then, you know, and then pull out any OpenGL stuff, any OpenGL specific stuff, and pull out any Vulkan specific stuff and move those into their own pots, which is what I'm sort of doing, but at the same time I'm trying to also stick to the stick at least somewhat to the book that I'm reading, so that I don't get so confused as to what I map things to later on, because this has been a multi-week process. We're up to what, I think this is like episode 19 or something. So, you know, we're like 19 streams into this, which is almost 19 weeks. And this is as far as I've gotten. It's not much. It's not much at all. And the other thing nice about LWJGL is that it's already got libraries, like suggestions of libraries that it uses for all kinds of things, not just, you got OpenGL, you got Vulkan, you've also got the Async library to load in models that I'm using. There's a menuing library that you can use. There's a couple of them actually, and a bunch of other things. So I mean, they've done so much work, and it just annoys me that they didn't, you know, it's almost like they did all this work and then they didn't like throw a party. Right? And by throw a party I mean put documentation up and show, like, here's how all this stuff works, and here's why this is better, and all that stuff. Yeah, it's I've been doing this for a little while, for a couple weeks. And I've been alternating between this and other projects too. I've been trying to do the game dev stuff at least once a week. And then I also have like a streamer bot that I'm working on and other things, which the streamer bot is closer to what I do normally at my day job, right? Which is just full stack web dev stuff. So I'm not really the only thing. The only thing that's stretching my brain there is the like working with video and all that stuff. And there's still some technologies that I don't use on a daily basis that I'm learning. So all these things are just me taking the time to just learn stuff that I wouldn't otherwise have to know for my job, but I just want to learn. So it's, you know, it's working out from that perspective. Associated with a party. Yeah, I know. I was trying to think of a good analogy to make, and I couldn't think of one. It was just like, it's like you know, you do all this work, but nobody knows how to use it. You know what I mean? No one knows what you've done because they're just using you as a pass through to the underlying libraries. You know, that's kind of the tricky part of this. It's like it would be nice if they went up on a mountain and said, like, here's how you use our stuff. Here's why you would use our stuff. We're not just a pass through kind of thing. We actually have some good features here, and then show how to use them and realistic ways of using them, you know? Because that's the other part that bothers me, is that there's so much documentation out there on GameDev, and a lot of it is you either get stuff that's like super PhD level dissertation stuff, or you get, you know, I just want to have text that flies on screen and rotates. You know, it's like you get the very bare bones things, or the very high level stuff, and sometimes you need something in between, and there's just not a whole lot of that in between going on. I would love to see things where it's like, you know, someone making a game that is, you know, it doesn't have to be like a real, like, oh, it's a production level game. Just making a game that is something that we would see any other day of the week, and just show the process of doing it from ground up. You know, and why certain decisions are made, and how certain things are work, and why they work a certain way, and things like that. And some of that's just hard to get to. Or it's buried in a video that's, you know, 6 hours long. And you're like, well, I don't know if I have an afternoon to watch this. Sure, and that's absolutely the case, right? Like, you know, these are unpaid volunteers for the most part, and why would they spend time writing documentations and all that stuff? And that's an absolutely valid assessment. The problem is that it's a dirty job, and somebody's got to do it, right? Like, because if nobody does it, then nobody benefits from it. Or, well, nobody benefits at all, right? Like, because at the end of the day, you've put in all this work, and if nobody understands what you've done, they're not going to utilize the work that you've put in, right? That you've slaved over. So it's like a catch-22, right? You kind of have to do the dirty bits in order to get the adoption levels and get people helping you out more, get more people helping out, get more people offering suggestions, and get more people excited about what's going on, and get more people using all the hard work that you put into it, right? So it's like, it's kind of like what I say at work is I've always been a big, we need to stay we need to keep upgrading our libraries, our third-party libraries that we use kind of person. We don't have to be bleeding edge, but we have to be at least up to date, because things change radically from one version to another sometimes. The JVM is constantly being updated. Bugs and security issues are constantly being found. And if no one is monitoring that stuff, you fall out of the mainline updates very quickly. And eventually, when it becomes apparent that you need to update your libraries that you're using, it becomes a huge chore and a huge undertaking and a ton of time and money and everything else that could have been avoided if just someone did the dirty work, right? Which is someone sat there and said, okay, on each new release, I'm going to take some time out of my day and I'm going to look to see if there's been updates, what's being updated, you know, is there security patches, all this stuff, and keeping your application relatively up to date on things. It is what it is. Or maybe develop a hit game that sheds some light on the library, like Balatro, which uses Lua and the Love 2D library. Yeah, sure. I mean, I don't need to do that for LWJGL, because, I mean, Minecraft was written on that, so I don't think you get any more popular than Minecraft. So, you know, that's the library that Minecraft uses. But no, I get what you're saying. It's like it brings a spotlight on what you're working on when you create stuff with it. But it doesn't eliminate the need to learn it either. Right? So, like, I'm wondering how much, like, since Balatro brought Lua and Love 2D library into the mainstream, have the resources around people learning Lua and people learning Love 2D, have they improved? Right? Or is it still, you know, is it rough to try to deal with? You know what I mean? So we have a source and destination buffer. This create index buffer brings back this record. But it's private, so this isn't used outside of this. Transform models. Is the only public one. I think the other thing that's bothering me here is because these are all static, it suggests that the mesh data is going to be changing, which I'm not entirely sure is the case. I mean, I suppose it could be the case, but for my purposes, once I've loaded the mesh, it's loaded. Like I don't have to screw with it again. So I called this Vulkan Mesh because I'm like, well, let's just store the vertex and the index buffers here. Like, is there a reason for me not to keep... Is there a reason for me not to keep these buffers around? Because we're doing a return new transfer buffers, which is coming down into... Just coming into here. They're looping over mesh data, which I still don't understand why that's a thing. Because there's an array of vertices and there's an array of indices. And there's an array of texture coordinates. I don't know why there would be a whole list of stuff here. And then we're creating a Vulkan mesh with the destination buffer of the vertex and indexes. And indices of the mesh data? Oh, the length, sorry, the length of that. So... For static data, I personally keep the buffer hand around. Yeah, that's what I'm trying to figure out, is why they're going through the effort of because they're so it looks to me like so they're doing the transfer here. So they're taking all the vertices and indexes and they're throwing them through out to the GPU and having them transformed. And then they're reading that destination buffer into the mesh, and then they're adding the mesh to the list of meshes for this model. But that's the part that's confusing me, is that it's when would you have multiple meshes? Like when would you have multiple lists of vertices and indices for the same model? Because if I'm loading up a model, I'm loading all that stuff up in one. I mean, I know that there's whatchamacallit, see, they do have a list of meshes, not meshes, texture coordinates, indices. Yeah, like there's only there's a list of indices. For each face, and I take all of those together and map them to an array. So every face, every indice for every face. So you can animate them independently. Yeah, I haven't thought about animation yet. Okay. Okay. So, okay. animate them independently. I'm trying to figure out what's tripping me up here is I don't necessarily like how things are being named, which I know is a stupid thing to be worried about right now, but like Vulkan model to me doesn't mean, it means something else. It like when I think of a model, I think of the mesh that makes up the model and anything else that would go with that. Well, I guess, yeah, which is kind of what they have here, but it's this whole thing is confusing me because it's like the mesh is, in my brain, the mesh is the combination of the textures, the materials, the indices, the vertices, and that kind of stuff, and then I guess yeah, I guess this does make sense. What's throwing me off here is I feel like these methods, the create indices buffers, the create vertices buffers, the record transfer command, transform, some of the transform models, not all of it, but some of this, it feels like this should be in the mesh because you're doing operations on the data from the mesh. And then a part of this method would be in the model that would then call the mesh to do stuff, and then I don't know. Maybe this is written correctly. It's breaking my brain right now. For me, a mesh is just the geometrical data, vertices, and indices, while a model may include the data relevant for rendering material mesh joints. You may have different instances of a mesh with a different material and call that a different model. But then I see what you're saying. In that case, would an entity would just be an instance of a model, right? Or would it, like if I put the same spaceship on the screen 25 times and 10 of them have different textures, would I have 15 entities with, would I have 25 entities with the same list of meshes? Or, well, yeah, they would have the same list of meshes in your example. Would I have 25 entities with the same model, or would I have 15 entities of one model and 10 entities of another model? That's what I'm trying to figure out. Like I'm all confused here, and I'm trying to figure out where there's something about this that's tripping my brain in the wrong way, and I'm trying to wrap my brain around this. An entity is even more general, which may or may not include a model. You may use entities that are not rendered but exist in your game scene. But in theory, okay, but in theory an entity would, even an invisible entity would have a slot for a model. It's just the model wouldn't be populated, right? Maybe the exact implementation may differ, but that's one way to... Okay. Okay. I wish I had... I wish I had better... These... So model mesh entity, those make sense from a English perspective. For some reason, they're not making sense in my head, because every time I see model, because this is so stupid on my part. Every time I see model, I keep seeing model view controller in my head. The MVC model that I use all the time in full stack development. So the model is the thing that holds all the data that is for, say, an HTML form, and the view is the actual HTML page, and then the controller is the back-end code that's actually responding to requests back and forth from the browser. And so, for some reason, for some reason, I see model and I keep thinking it should work like the model view controller does, where it just holds. It's just a pojo that holds all of the data backing the form. And that's not really the use case here, and it keeps throwing me off. And I'm trying to think of a better, not better. I'm trying to think of a different word that I can use that won't trip my brain so badly. Let's say you have a racing game with two players. If they use the same car, you'd only want to load the mesh once. Now, if everything else, model and textures, is the same, they may even share the same model. In that case, the two-player entities would have their own transform, but the same model. Okay. They use the same car, you don't want to load the mesh once. They would have, okay. But the other thing, using different materials. See, the other, I see what you're saying, and I kind of get what you're saying. What is the other question I have there is when you're loading a model up, right? Inside the model file, well, not really inside, but like the model file would have in theory, texture coordinates and material properties and stuff like that. So when you load that file up, are you essentially creating multiple models based on how many different material properties and texture properties are in the file? So if the file had like 3 different textures, 3 different material property things, you're basically creating 3 different models? Or is it more of, or is it more like you load the file up once, or you load the file multiple times? That doesn't seem like a good idea, but it might be. So it would have to be, yeah. And the thing is, I know, was it chapter 9, I think, of this book actually gets into full 3D models and stuff. Like, we're only doing a triangle for now. So a lot of this stuff is just building blocks on that. But I'm trying to get a picture of where we're going, because this is what's bugging me right now, is that there's, like, I'm trying to figure out how this gets populated in a way that isn't insane. Right? It's like, because with the other one, because all I did, and I realized, like, this worked for what I'm doing right now because I only load the one model up. But all I did in OpenGL was just like grab the entire, I grabbed the entire material list and I just created one model with all of its materials in it from what's loaded in. Which I guess, I mean, I don't know. But even here, I do a new mesh with just vertices, texture coordinates, indices, and colors. So that mesh then comes into here. I add it to the mesh list for that material. And see, maybe these words are all wrong. So that material, default material, material index, material mesh, and default material, and then the model. So the model has materials. It has a material list and entities. So I got a list of entities that use this, but I've also got a list of materials. So I don't really have a one-to-one mapping there. Huh. It's best to distinguish what data formats you ingest from, how you organize your data. Even though a file may contain material, textures, and mesh, that does not mean they have to be tied together. Sure. I'm just trying to figure out how to model that in a way that makes sense, that I understand what I'm trying to do. That's my issue right now. Is like, I'm all for keeping the data and the usage of the data separate, but I still want to. I would still like to model it in such a way that I know what I'm doing later on. And that's what I think this is the part that, this is the part where I struggle the most, is that because I haven't had the light bulb moment yet where things make sense. And because I haven't had that light bulb moment yet, I'm not modeling things well. And so every time I look at these classes and stuff, I get whiplash because I don't remember where I put anything or why things were in a certain place versus another place. And that's, and there's nothing, like, it's not a reflection on anything, like any of the code I'm looking at or anything else. It's just, it's me, it's entirely me not fully grokking all this stuff. And I'm trying to, like, I'm trying to get myself to a point where it makes sense. To me. I want to emphasize to me. I'm sure it makes sense to a lot of other people looking at it, but it's not jiving with my brain yet. And I'm just trying to get that aha moment where things click and I start to understand the rhyme or reason between things. I'd call the combination of mesh, material, etc. the model. So I'd load those components and then treat them independently. The model, okay. Which is kind of what I was thinking, to be honest. I mean, there's a lot of extra words floating around, like mesh and all that stuff, but, like, to me it's like, I wouldn't necessarily expect a, well, I guess I should expect it, right? Because I could have an object, a 3D file that has an entire scene in it, right? And then that scene could theoretically have multiple models in it, although I think that might start getting confusing, but I guess theoretically it could have multiple models in it. And the question becomes, do you make the assumption that there's only one model and then treat that entire scene as one model, or do you pull out the individual models from it and treat them as the separate things that they should be, which would be more flexible, but at the same time, what does that look like, I guess, and how does that work? Is the hard part there. So I think what you're saying makes sense, where it's just like load up the file, take all the data out of it, and just model that data as a model, and then put all that data into a model, and then from there you figure out your entities and stuff. Okay, your entities and material. So it would be, okay. So I have material here. So what else do I have in material? Okay, so for material I have the texture path, the list of meshes, the colors, the normal maps, the reflectance. Okay. So it would be so I have mesh list in here, but in reality it would not, mesh list would not be in here. It would be under model, and material would just be this stuff and possibly more stuff, because I haven't even gotten into the material, like the MBR or whatever it is stuff. Haven't even gotten into that yet. So then you would have a model. So let me see if I can, do I have something on this computer for modeling? What do I need? Damn. That's not it. I thought I had balsamic working on here at some point. I do have it downloaded. Models. Maybe the following explanation is easier. You'll usually have entities in your game. Whenever your entity is something that is rendered onto the screen, you'd attach a model to it, which may be a mesh and a material. Different entities may have different models attached to them, which may use the same or different meshes and materials. Okay. Which I think is what I was thinking, I think. We do new wireframe. No, that's not what. File, new project. This is probably not the best. Well, I had like a modeling thing, but whatever. You know what? I need something else here. See if this works. Looking for what? Oh, here we go. That I don't like that at all. Is this literally just a paint program? There you go, flow chart. Sure, just something here. So we've got a model. I'm just trying to visualize what's going on here, because my brain is breaking right now. It shouldn't be breaking, but it is. It just is what it is. So we have a model. So in here, you've got got a mesh, which has okay. It's a lot to take in. And so you've got a mesh, and then that is that, and then you've got a material. Which has what did I have in there? So colors and texture path. So colors, texture path, blah blah blah. Okay. And then Got lights, animations, skeletons, cameras. I'm not going to deal with those just yet. But those are there. Okay. It's got uniforms for the mesh lists, all that stuff. So that's just going to the mesh. You've got texture, which is just literally the texture that's been loaded. But that goes into, that's its own thing. Right, that's not in mesh, is it? No, I don't think, I think I handled texture completely separate from everything else. Because there's an emissive texture too. So I have a texture map. So texture has a name, which is the ID there, and that I believe is in. Where do I put that at? I don't even know. I might not even have that anywhere. Though I'm definitely loading them. Yeah, I have it. Okay, so I haven't attached the texture to anything. I've just put it out there. Huh. Material may consist of multiple textures and some parameters. Okay. So we'll say that for our purposes, we'll put texture here. Texture cache will be over here. And then this will have okay, and then so that's the model, and then the entity. To an instance of the model. Is this kind of what we're going on? I know this is a highly simplified view, but this is kind of what's going on in my brain. Make that plural so I know. Oh, that's interesting. I wonder why that's not showing up. That's interesting. Yeah, I see what you're saying. It's only showing the browser. I have this. I have LibreOffice Draw open in full screen. Wait, what? Oh, it's not even showing the right. How did that happen? I'm switching between screens here. It's not showing the right screen. What is going on there? Well, that's strange. Oh, I think it's completely frozen. Oh, maybe that's what I heard earlier with that ding. Let's see. Let me try something here. That's weird. Okay. How long has that been doing that? That's weird. That's completely frozen. What you're seeing. That's a first. Hang on a second. No, I've been swapping back and forth between my code editor and stuff. I didn't even realize that the screen wasn't updating. What is... How in the world did that happen? I have a feeling it lost connection with my capture card altogether. That must have been the sound that I heard. But like an hour or two ago. Well, that's interesting. Yeah, that has not happened ever before. Like, if I do vision, I don't think this is gonna work. Okay. Well, this is a thing. What's the likelihood if I unplug and plug it back in again, it'll work? Hang on. Okay, I'm gonna have to stop OBS and start it again. So let me stop the stream and start the stream again and see what happens here. Hang tight, friends, because this is very strange.